Hi guys, Miss Malik here. Today we're going to do exercise 4G from your methods textbook. We're determining some rules for polynomial functions. So here they say there are 4 points, -1, -18, 0, -5, 1, -4 and 2, -9. They're saying that these lie on the graph of ax cubed plus bx squared plus cx plus d, and we want to find the values of a, b, c and d, and hence then we can state the actual equation of this polynomial. So the first thing to do, as you would with simultaneous, or when you have 2 points, you would form some equations. The first one, -1 and -18, if we substitute those in, we get -1 cubed times a, which is -a, plus -1 squared times b, which is b, plus -1 times x, which is, -1 times c, which is just -c, plus d, and that equals -18, because -18 is your y value. We do the same for the others, so we substitute 0 for x, giving us d equals -5, and we substitute 1 for x, giving us a plus b plus c plus d equals -4, and then we substitute 2 for x, giving us 8a plus 4b plus 2c plus d equals -9. These are our 4 equations. Already we can see one piece of information, and that is that d equals -5. So that was easy. We now have to find the other 3 though. Let's see, if we look at the equations, we can see that these 2 that I've highlighted, if we're to work with those, we may be able to find another piece of information. So if I then am to add them together, then I would say -a plus a, well, that's 0, so that gets rid of a. b plus b gives me 2b. -c plus c gives me 0. And d plus d gives me 2d. And then don't forget to do it on the right as well. People sometimes do that. It's a bit of a silly mistake. So -18 plus -4 gives me -22. So that gives us the equation of 2b plus 2d equals -22. Now, what we can do is we can substitute d as -5, because remember we found that d was -5. So 2b plus 2 times -5 equals -22, giving us b equals -6. There's another piece of information there. So now we only need to find a and c. Let's substitute in b and d into one of the equations. I've chosen the third one, a plus b plus c plus d equals 4, or -4. So a plus -6 plus c plus -5 equals -4. A plus c equals 7. Let's substitute into the last one. 8a plus 4 times -6 plus 2c plus -5 equals -9. Let's tidy that up. We get 8a plus 2c equals 20. Let's take that equation there and the 8a plus 2c, it should be others as well, and we're going to first of all times a plus c equals 7 times 2. So we get 2a plus 2c equals 14. Now we've got 2 equations we can work with. The 8a plus 2c equals 20 and 2a plus 2c equals 14. Let's subtract those. I think you can probably see what's going to happen here. It means we're going to eliminate the c. 8a minus 2a is 6a. 2c minus 2c gives us 0, so that eliminates c. 20 minus 14 is 6. 6a equals 6, so a equals 1. So there we go, we've now got a as well. We only need c. By substituting a into one of the equations, I'm going to substitute into a plus c equals 7. So 1 plus c equals 7. C must equal 6. So there are all our values. A equals 1, b equals -6, c equals 6, and d equals -5. I highlight that because that is my answer. If the question asks you to find the equation, you would then have to substitute those into f of x equals ax cubed plus bx squared plus cx plus d. Make sure you read carefully. Let's do that on the calculator. So what I do, I go to my main screen, and in there I go into 2D. Once I'm in 2D, I can click on this, this button here, and that's where I can type in more than one equation. So for simultaneous, here it is here. What I've done, I've typed in my equations when I substitute each of the points in. So when I substitute -1, -18 into ax cubed plus bx squared plus cx plus d, I get -a plus b minus c plus d equals -18. I do the same for the other three, just like I did in the previous slide where I solved it manually. I then must make sure that I put in A, B, C and D. The calculator screen wasn't large enough to show you D, but D is there as well. I put a comma in between each, so A comma, B comma, C comma, D. That goes, there's like a little box where you put those in. Here's the comma there. When I click EXE, it then will give me A equals 1, B equals -6, C equals 6 and D equals -5. Be careful, because a common mistake is that people will just always write that down as their answer. In this question, that's what you would do, but sometimes they'll ask you to state the equation of the curve or the polynomial rather, and therefore you need to substitute those into the form that's given to you. Next, they want us to be able to look at graphs and to be able to find rules for those graphs. So here, I've been given a graph, and I have to find what the equation of that polynomial is. So let's see what we would do there. First of all, you know that where you've got just where you've got -3, 1 and 4, these are the x-intercepts. These are the x-intercepts. So we can say the solutions would be x is -3, x is 1 and x is 4. So if you had to write in brackets for those, you would write x plus 3, because x would then be -3, x minus 1, because then x is 1, and x minus 4, which means x is 4. Well, that's all well and good, but we wouldn't know how fat or skinny the graph is, or in other words, how much it's dilated. So the form of it would be a, x plus 3, x minus 1, and x minus 4. That's quite easy. Now, though, we need to solve for a. And we can do that because we've got a point. Let's substitute in that point. When x is 0, y is 4. Sub it in, and you'll find that 12a will equal 4. Therefore, a equals 1/3. And that's it. You've done it. You now can state the equation of the polynomial to be y equals 1/3, because that's what a is, times x plus 3, x minus 1, and x minus 4. That's it. Not so hard. This one here is a little bit different because we've got x just touching the -3 there. What we can say is that is then two solutions. So x plus 3 and x plus 3. Because that's, if you think of it like that's, it looks kind of like a quadratic without the, if you just have the part of it touching the -3, this part here, it looks kind of like a quadratic. So you can say, well, it's like squared. So x plus 3 will be twice there. We also go through the 1, so that's x minus 1. We want to find a, so we've got a, x plus 3, x plus 3, x minus 1. Let's sub in that point of 0, 9. X is 0 and y is 9. We end up with -9a equals 9, and a equals -1. So therefore, our equation of this curve will be y equals -x minus 1, and then x plus 3 squared. So when you're going to touch the axes, and it just sort of, it touches the axes and then goes up again or down, it means that we've got it squared, all right? It doesn't cut it through. It doesn't go through the x-axis, it just touches it there. That's it. That's how we determine rules for our polynomial functions.